right? Okay, which of the following statements describe a phenomenon which cannot be explained by hydrogen bonding? Okay, ice floats on water. Can that be explained by hydrogen bonding? Okay, so if you look at water, right, water actually has 2 bond pairs and 2 lone pairs, and the angle is 104.5. So when it forms ice, okay, the water molecules come very close to each other. Okay, when it becomes ice, the water molecules come very close to each other, and they'll form very, very strong hydrogen bonds, right? So the water molecules are really very close to each other. All right, just let me draw it out first. So actually about O, okay, I'm going to say this, about O, all right, about O, there would be actually 4 bond pairs. I'm going to put 4, I'm going to put a bracket here, bond pairs. But actually when I say 4 bond pairs, actually it's really 2 bond pairs and 2 H bonds. Okay, and all this is about O, about O, right, about O. So because of that, we take it, if it's 4 bond pairs, this angle will actually end up becoming 109.5. all right. So from water, which is 104.5, become 109.5, you can see that the bond angle actually increases. Just implies the volume actually increases. So imply what happens to density? So density is actually equals to mass over volume. So when volume increases, density actually decreases. That's why ice floats on water, right? That's why ice floats on water. Okay, let's look at the next one. Which cannot, which one cannot be? So this one can be explained. Okay, I'm going to draw 2-nitrophenol. So you must be quite familiar with the name 2-nitrophenol. So this is phenol. Let me just draw phenol. This phenol. All right. And these are the labeling. This is carbon number 1, number 2, number 3, number 4, number 5, number 6. So when you say 2-nitrophenol, which means the nitro group is on the second carbon here. Okay, this is the nitro group. Okay, see that? This is the nitro group. All right, I'm going to draw 4-nitrophenol now. 4-nitrophenol. So this is 4-nitrophenol. So you realize that for 2-nitrophenol, there's actually intramolecular H bonds. All right. So because they are intramolecular H bonds, there will be these are intramolecular hydrogen bonds. It can form less extensive. I put less extensive intermolecular H bonds. Okay, it can form less extensive intermolecular H bonds. So if it forms less extensive intermolecular H bonds, less energy will be needed to overcome these intermolecular hydrogen bonds. It will have a lower boiling point and it will be more volatile. Okay, more volatile, which means this statement is correct. Okay, this molecule doesn't have any intramolecular hydrogen bonds, right? Okay, ethanoic acid forms dimers when dissolved in benzene. Yep. Okay, benzene is actually non-polar, so which allows ethanoic acid to form a dimer. Okay, it enables ethanoic acid to actually form a dimer. So this is how you draw it. Okay, so it can form a dimer over here. So yeah, so this is actually your H bond. Okay, so it's also being explained by the last one. Okay, B, why is B wrong? Okay, so why is B wrong? The boiling point of carboxylic acid increases with increasing MR. So carboxylic acid, maybe I'm going to just draw the one simple carboxylic acid. Alright, so this part of carboxylic acid will form H bonds. Alright, and this part of course will form IDID. Alright, so as the MR increases, so maybe let me draw you another molecule of carboxylic acid whereby it has a much longer carbon chain. Alright, so the same thing, this part will still form H bonds, but here the higher boiling point is because of the more extensive IDID. Alright, more extensive IDID here. Okay, so which means the boiling point increases with increasing MR is because of the more extensive IDID. Okay, so it's nothing to do with the hydrogen bond, so it cannot be explained. So the answer is going to be B. Alright, so this question is a bit long, but because there's so many concepts to think about.